Viewers of this channel should all know that black holes are extremely powerful and terrifying existences. 77 billion light-years away from Earth, there is a celestial body named Terror 8, whose light is even brighter than that of superstars, and it is one of the black holes. It devours stars and emits terrifying radiation in the form of energy remnants. Writers have observed these cruel methods of destruction in space many times. If we look at black holes from different angles, what would they look like? Hello, viewers. It may be hard to imagine, but its color is actually white and extremely fluffy. Black holes can coexist with stars for tens of billions of years, extending the stars' lifespans and even reviving them. But how is this possible? Welcome to Global Fields Chanel. After watching this video, you will understand everything. Recently, scientists have proposed a hypothesis regarding powerful cosmic monsters. This method is innovative and highly complex. Some celestial bodies, like massive cosmic cocoons, gradually siphon the vitality of nearby stars. If you are a regular viewer of this channel, you might have already noticed that this topic is related to energy harvesting stars, including black holes. If a star has a black hole in its core larger than a micro-black hole, then the star will naturally use it as an energy source. During this massive energy extraction process, the star will activate its cooling system to prevent overheating, thus avoiding the ejection of its outer shell into space. To cool its core, the star's outer layers expand and transform into a red giant. Many stars, like the Sun, will face this fate once their nuclear fusion reactions end. A red giant containing a primordial black hole has a slightly lower density and turns red. This type of star is called a red lepton star. Currently, the most massive celestial bodies we know of may pale in comparison to these exotic existences. These enormous bodies could be considered breeding grounds for black holes, an unimaginable connection. If we confirm that stars are nurturing black holes within, does this mean they are simply sacrificing themselves to these terrifying monsters? Not at all. Instead of mindlessly being consumed, these stars attempt to use black holes as energy sources, a strategy that is entirely unique and unprecedented. The immense energy of black holes significantly increases the brightness and size of these stars to unparalleled levels. An example is Stephenson 218, one of the largest stars in our universe. If placed next to a massive celestial body of this type, Stephenson 218 would appear as small as a tennis ball, showing just how massive these exotic stars are. If the Sun were in front of such a gigantic body, it would be nearly invisible. In reality, it is impossible to compare these celestial bodies directly. Such entities have existed in the universe for an incredibly long time. But what is the true identity of these giant celestial objects, and where do they ultimately vanish? These stars are sometimes referred to as black hole stars, an extremely dense and luminous hypothetical celestial body that may have existed in the early universe. According to scientists, the early universe was like a vast balloon composed mostly of hydrogen and helium, with almost no heavier elements. Because of this, primordial stars had incredibly high masses. Unlike modern supergiants, these stars did not explode in supernovae. Instead, when the matter in their cores collapsed beyond a critical threshold, they directly formed black holes. In contrast to modern massive stars, which struggle to form black holes due to ongoing fusion reactions, the birth of these exotic entities follows a different mechanism. According to one theory, they may have emerged directly from darkness, not in a mystical sense, but through scientific processes. Research suggests that these stars could have formed within dense clouds of dark matter, using their own gravity to actively consume cosmic matter. When they overfeed, the material in their cores collapses and forms black holes. This process is similar to a stellar perpetual motion machine. Throughout its long existence, such a star does not rely on fusion for energy, but rather on the decay energy of material falling into its core black hole. By constructing theoretical models, dedicated scientists have gained insight into these cosmic behemoths. Their diameters can reach hundreds of billions of kilometers, an almost inconceivable scale. These stars absorb the radiation emitted by black holes, achieving temperatures as high as tens of millions of degrees, making them even more extreme than what we might consider hellish. If we could visit these stars, we might be able to see their presence from vast distances. They would appear brighter and more prominent than most galaxies. Unfortunately, their extreme lifespans do not last forever. Over time, as energy dissipates, their temperatures gradually drop, their outer shells become transparent, and their brightness declines to about 4,000 Kelvin. Eventually, they lose their dynamic equilibrium and rapidly disperse, leaving behind only an intermediate mass black hole. Intermediate mass black holes are relatively rare in the cosmos. However, astronomers have identified several candidates, such as the X-ray source HLX-1, located in the Edge-on galaxy ESO 243-49, approximately 219 million light-years away from Earth. HLX-1 has an estimated mass about 20,000 times that of the Sun. The critical question is whether these celestial bodies contain the DNA of ancient quasars. Scientists are actively searching for answers. Another fascinating type of celestial body is the gravastar. The question that led to their hypothesis was, what happens to matter swallowed by black holes? Traditionally, astrophysicists believe that matter collapses infinitely toward a singularity. However, if this were entirely true, matter should not be able to re-emerge. Some researchers speculate that certain massive stars may have avoided turning into black holes, instead becoming objects similar to black holes, known as gravastars. Gravastars are hypothetical, extremely dense objects sustained by vacuum energy processes. Unlike black holes, they do not have event horizons. In other words, there is no boundary preventing internal information from escaping. However, the gravitational pull at their surfaces is still strong enough to trap even light. A thin shell of normal matter covers the surface of a gravastar, but this outer shell is also its greatest weakness. According to models, this shell cannot withstand the immense forces acting upon it, leading to a sudden collapse. Yet, physicists at Frankfurt University have recently calculated that gravastars might not be doomed after all. If multiple gravastars could cluster together, forming structures akin to Russian nesting dolls, they could stabilize each other. This theoretical model, named Nesta, suggests that gravastars interlock while being separated by layers of dark energy. This configuration resembles an immortal cosmic structure. Nesta's unique setup could balance gravitational and dark energy forces simultaneously. Unfortunately, our current technology does not allow us to observe inside black holes, making it impossible to verify these ideas. Meanwhile, astronomers have been studying another peculiar phenomenon: dark energy stars. Initially mistaken for black holes, these objects deceived scientists for a long time. Researchers at the University of Hawaii have been investigating them, naming them dark energy stars. Like gravastars, dark energy stars exhibit unusual behavior. Instead of containing a singularity, they may house dark energy at their core. Some studies suggest their shapes resemble tori due to quantum mechanical effects. Astronomers hope to use future telescopes, such as the proposed Event Horizon Telescope, to explore these mysterious objects. The universe remains full of surprises, and we eagerly anticipate new discoveries. If you found this information intriguing, be sure to like and share this video. Until next time, goodbye.